Hello everyone and welcome back to my YouTube channel. Today I'm going to show you how to capture bathymetric data using the OceanAlpha SL20 USV, the USR-VCOM virtual serial software, the Echologger control program, the OceanAlpha USV BaseStation software, and the Hydromagic software. This comprehensive guide will cover everything you need to know to get accurate bathymetric data for your survey project. Now, let's note that before all this configuration and data capture is undertaken, the OceanAlpha SL20 USV is connected to a laptop which will be used for the data capture. Take note that the GPS and the EchoSounder on board the OceanAlpha USV SL20 is what will be configured for the data capture subsequently. Now, let's get started. Setting up the USR-VCOM virtual serial software. This software creates a virtual communication port to communicate with the USV. Open the USR-VCOM software and configure the virtual COM port. Make sure to match the baud rate, remote IP address, and the remote port to establish connection. We'll set up the Echologger control program. This program manages the EchoSounder, which is crucial for capturing bathymetric data. You open the Echologger software. You define COM5 for the Echologger port, and then COM6 for the GPS ports. The official baud rate is 115200. The range defines the range of the EchoSounder. That is how deep the EchoSounder can go. Then you have the TX length, which defines the set transmitted pulse length in microseconds. The interval defines the interval or the repetition rate between the pulses in seconds. Dead zone / millimeters. It defines the near field zone where detection is ignored. Below this depth, the sounding is ignored. The offset millimeter, which defines the offset, the position of the device in millimeter. The altimeter threshold. The altimeter threshold in percentage of full scale, and the gain GB, decibels, describes the analog gain of amplifier in decibels, and the speed of sound, which is a default of 1500 meters per second. Now for the output mode, we select or we use the altimeter MEA, and then when all these configurations are done, we click connect to check the readings from both the GPS and the EchoSounder. Once configured, start the EchoSounder to begin capturing depth data. Make sure the data is being recorded and displayed correctly on the screen. Terminal software used for configuring the OceanAlpha SL20 for the data capture is the Hydromagic software. Now, to configure the GPS and the EchoSounder on board the SL20 using the Hydromagic, you go to Options, Preferences, you select your device, then you select your Echologger, click the Configure button, and set your connection type, your circuit type, and your host IP. Set the protocol as well. When done, you press your OK to activate your Echologger. It should turn green when it's fully integrated and transmitting data. Do the same configuration for the GPS. Now to connect the GPS, you set the connection type, the circuit type, the host IP. Now you take note, the only difference between the connection for the GPS and EchoSounder is the host IP port. For the GPS is 4000 and for the EchoSounder is 4003. And when all these settings are in place, You click OK to finish the configuration. Note the Hydromagic NMEA switches from green to red, indicating connection. To configure your transducer, go to Options, Preference, select the Calibration tab, and then you input your transducer distance. To calibrate your motion sensor, you select Use Motion Sensor Recording when processing raw data. You calibrate your heading mode and the heading offsets similarly by selecting the appropriate definitions. Configure your sensor. Click on Manage Sensor Definitions and update your configuration parameters based on the USV to be used. When all configuration from the OceanAlpha software, the USR-VCOM, and the Hydromagic software have been fully integrated and fully functioning, we realize from the left tab of the screen that the GPS positioning and the EchoSounder parameters are all indicating green, which means the USV is broadcasting and receiving GPS and sounding data properly. In the event you are using a software for data capture, either on the OceanAlpha BaseStation software, the Hydromagic software can also be used for configuring the EchoSounder. Displayed on the screen is a tab responsible for editing the Echologger transmitter. Edit to shoot the USV and apply when done. Under navigation data, select the data view options and then check the low frequency for depth when using a single beam EchoSounder. From your display, go to Options, Preference, and select your unit. Select acres for your area units and cubic meters for your volumetric units. Adjust the other parameters according to your own discretion. Go to Options, Preference, and select the RTK tab. Now, to set the appropriate heighting system, we check Treat ellipsoidal height as Orthometric height. This ensures that the USV uses the Orthometric height instead of the default ellipsoidal height. Under the RTK tab, you select the required Geoid model to be used for your data capture. If the Geoid model is not in the list of the drop-down provided, you can as well create a new Geoid model by downloading it from the Hydromagic site, where we can manually input into the system to be later used for our data capture. Now navigate your Geoid model file and import them directly into the software. After adding the model, we update the Geoid model created, that's the EGM 2008, into the Hydromagic Geoid model table. This is done by selecting the zone in which it is and giving it a name, subsequently clicking the OK button. After doing that, we realize it has been updated into the Hydromagic Geoid model database. We OK when done. Under the Preference RTK tab, you can input the antenna height manually by measuring, or you can use the height provided by the manufacturer, usually in a soft copy format. Under Preferences, you can go to the Alarm tab and set the various type of alarms which we need whilst capturing our data. You click on the Setup, edit the various alarms accordingly. The final edit to undertake before data capture is the GPS configuration. Now, connect your GPS wirelessly to the web with the IP and then the username of admin and the password admin. Now you go to Data Transfer, click on Data Flow Configuration, and edit the settings accordingly. You edit the settings to suit what you have on screen. Now basically what is going on is we are setting the intervals or the rates for which the data or the capture data intervals is to be set. You will edit it for the various components individually until you are okay with the output. You click enter when done to continue. We repeat the same process for the base station as done previously. Then we can now continue with the data capture. Now, let's move on to the OceanAlpha USV base station software. We open the base station software, connect it to the USV via the virtual serial COM port. We load the boundary and route data that was previously imported from your mission created. When the software interface is initiated, you make sure the USV, the positioning, and the heading at the lower right corner are all indicating green, which indicates that the mission is a go. It is vital to edit your waypoints before the mission starts, so as to prevent wasting time and the battery for long travel time just to begin the mission. You can edit the waypoint number, delete or reverse the waypoint. In this case, the ending waypoint is reversed to the start waypoint. You can swap two waypoints in the event you want to skip a line. And then finally, you can reorder them manually. You can as well import a running mission so as to skip a selected number of routes. All these are done to aid in efficient data collection. Before we start, make sure the USV is at an appropriate location close to your starting point to prevent it from traveling all the way to begin. This is done by activating the home button and then dragging your USV to the desired point. Select the return to home feature on the OceanAlpha BaseStation software in order for the USV to return to home when the mission is completed. Start the mission by setting the USV on its predefined route. Monitor the USV's position and status in real time to ensure it follows the planned path accurately. Start recording. On beginning the mission, the USV travels to waypoint number 1 to begin the data capture. During the data capture, there is live transmission between the USV SL20, the OceanAlpha wireless base station, and the software, which entails the OceanAlpha BaseStation software and the Hydromagic software. As mission parameters are set, a USV is deployed in the water. We begin its autonomous operation. The SL20 utilizes its advanced navigation system to follow the specified route accurately. While onboard sensors and EchoSounders capture high-resolution bathymetric and environmental data, the collected data is logged and transmitted back to the base station software for live monitoring and subsequent analysis. Throughout the mission, the base station software allows operators to track the USV's progress, view real-time data, and make adjustments if necessary. This autonomous data capture process ensures reliable and consistent data collection, making the SL20 USV an invaluable tool for researchers and surveyors aiming for high quality and comprehensive environmental assessments. As such, the USV follows the route from waypoint number 1 to the very last waypoint. The USV stops upon mission completion. On screen is a preview of the video footage of the bathymetric data collection. The video can as well be recorded whilst the mission is being undertaken. Upon completing this mission, the SL20 USV returns to home. Upon completion, the sounding data collection. When the entire mission is completed, we stop recording data. Alright folks, we've come to the end of another exciting video. Don't forget to like, subscribe and hit the notification bell for more cutting edge savvy tutorials and insights. See you guys in the next video.